Hello, what's up everyone? It is Mr. IO here for another video. Today I'm going to be doing a quick tutorial, well, hopefully quick, on the carry look everywhere logic that I used in my previous Reddit post. So we're just going to be doing it on 4 bits, not 8, because I don't feel like doing a whole 8-bit one. It took me quite a while to wire that all up. Okay, so first you should be familiar with a few things. We have carry, and we have the sum. Or, alternatively, propagate and generate. So the sum is this output right here. Whoops. See if I flip this, that output turns on, this one turns on, to both, turns off. Same with this right here. This is the carry, or generate, if you will. So if we turn on one of these, nothing happens, one of these, nothing happens, turn on both, and this one turns off. So this is very useful, very useful. We're going to be using this a lot. So for making the routing table, we're going to make a new board. We're going to make it 6 tall. We're going to make it 5 wide. Just going to position this right. There we go. I might as well position it in the middle here. Just like so. Now we have to first invert the output of our propagates here. So I'm going to invert these. I'm going to add an inverter here. Connect all these up. Connect all these up. Connect all these up. There we go. Got that inverted. And our generate here is already inverted on its own. So that's nice. Okay. We're going to be using some through blotters here to organize everything. Place them like this, so we don't need that one. So basically, the top row, and I'm going to label this actually. I'm going to make it 1 by 2. Just like that. And I'm going to be labeling the top one, the P. Might as well call it propagate. Generate. Okay. We're going to be connecting all the propagates to the top. Just like that. Okay. All the propagates connect to the top. So if I enable 1A, turns that one off. 2A turns that one off. 4A turns that one off. And 8A turns that one off. Like that. So those are all the propagates. That's all that is. So the generate, that's this one right here. And we're going to be leaving one at the end here for our carry in. So let's do that. Do that. Do that. There we go. That's good. I'm going to set up my carry in here. So we're going to grab an inverter. Connect that up there. Give ourselves a switch. Connect that to that. Now if I turn on the, I'll label this actually. Carry in. If I flip it, disables that one. I turn on both of these, disables that one. Turn on both of these, disables that one. Both of these, disables that one. And both of these, disables that one. Okay. Now, I'm going to make a new board. It's going to be 1 by 1. I'm going to place it right here. I'm going to make a few of these. I'm going to make, in fact, 5 of these. Just like that. I'm going to make one more. I'm going to place it on top. I'm going to make one that's 1 by 2. Place that on top. One more, whoops. One more, which is 1 by 3. There we go. One more, which is 1 by 4. One more, which is 1 by 5. There we go. Now we're going to put inverters on all of these. And start connecting. Now this is where carry look everywhere logic kind of comes in. So I'm not going to be explaining why carry look everywhere works, but I'll show you a pattern for building this type of routing table where you're going to know how to build an infinite amount of bits of this. Any amount of bits you want. But if you want to know how it actually works, I'd recommend Googling some videos on how it works. So this isn't a tutorial on how carry look everywhere works. It's how to make it. So the generate, we need to connect here to each and every single so the carry in here needs to connect to each of the first ones of these, right? The generate number 2 here is going to be connecting to all these. Okay. This generate number 3 connecting to all these. This one connecting to these two. And finally, this one connecting to this one. Okay, there we go. Before we go any farther, I'm going to add some pegs down here. And we're going to be connecting all these pegs later, but I'm just going to leave them there, so we're reminded to do that. Now, for the propagate here, for each like row of inverters that we move up, we're going to include one more propagate. So right here, nothing. Generate 1, just use generate 1. Okay, the second row here, I'm going to label these actually. You know what? I'm going to make this a lot simpler. I'm going to call this CI, because that's just the carry-in. Right? Carry-in goes directly to the generate, which goes straight to there. So this is the CI. This is C0, or carry 0. Whoops. C0. This one is C1. This one is C2. This one is C3. So for C0, we have to include propagate 0. All right. For C1, we have to include propagate 0 and propagate 1. As well as for this one, we have to include the propagate that's in front of it. Okay. Going back to this one right here, we need to be including this propagate, and this propagate. This one, we need to be including this propagate, and this propagate, and this one, just that propagate. So as you're seeing, it's pretty much every propagate. If we're trying to decide for now C3, starting at this generate, we want to include that same propagate, as well as the one above it, as well as the one above it, as well as the next one that we haven't used yet. So that's this one, because we don't have any connections to it. Just like that, connect that. We do that, and then include that. So I hope you're seeing the pattern here with what we're doing. And there we go, we're done. We just made our CLE routing table. So maybe you don't quite understand what's going on here. Basically what we're doing is, for example, for this one, what we're saying is that this carry, we want this carry to turn on if one, we want that carry to turn on if this, right? And like carry in. See, this one just turned on. Because if we're doing like this right here, we're doing, what is that, 15 plus 1. We want this to turn on. We want this carry to turn on. Because we needed to know that, when we turn on carry in, we want the final carry to know its value without having to know the value of these carries. So you're seeing here that none of these carries are actually linked together. They're all completely separate. And they're all calculated at the exact same time in 2 ticks. Now, these are just the carries. These are not the actual outputs. So we need to delete these because these aren't the actual outputs. Okay, disable these. To connect these to the output, I'm just going to grab an XOR here in a minute. First, we need to connect all of these up. Just like that. Connecting all these up. There we go. Now, for an XOR here, we can... I'm not going to load in an XOR. I'll show you how to build this one right here. So it's pretty simple. All you got to do is you got to grab an inverter. Well, we're going to need an inverter anyway. No, never mind. I'm getting confused here. Sorry. So I need to put 2 inverters like this, one behind it. Place these like that. It's going to be our input right here for one side. So I'm going to use a blotter. There we go. Connect that up like that. And over here, I'll use a inverter from the propagate. There we go, just like that. And then we're going to OR the two outputs. Okay, let me build another one. This might take me a second to build all these, so I do apologize if you get impatient. There we go. Connect all these XORs up. And because we already made the carry calculation previously, we don't need to do anything with these XORs. These aren't half adders, by the way. These XORs are just literally going to be XORs, right? Because we've already calculated what each carry is going to be using this routing table we just made. So connecting up all these are the carries. Connecting all these up. And we're going to need to use a little peg here, probably, just to make sure that that works. So the peg. Now you'll notice this carry here is not used. Well, why is that? Well, that's actually the carry out. I made that for us. You didn't actually have to make this last one if you just for an adder. You just make it for an adder, but like, you know, everybody likes a carry out. So this is count slash or yeah. This means 16. This is the carry out. Okay. Here we go. Gonna finish building these XORs. Or these. Or these. Or those. Okay. I think, yeah, we just need to connect these up and then we're done. Okay. Like that. Like that. There we go. Okay, and we are finished with that. Now, if we do the carry in here, actually, I'm going to add some lamps here just so it's easier. I guess I'm calling them lamps because I'm thinking of Minecraft. I guess they're displays. Can add some displays here so we can look at what we've made. If we add 1 plus, just do carry in, it's 1. 1 plus 0 is 0. I mean, obviously, 1 plus 1 is not 2. And the issue is that we didn't actually connect these at the end here. I did forget to do that. There we go. That was it? That was all I messed up? Okay, there we go. That's 2. Okay. If we add, let's see here, 3 plus 1, it's 4. The nicest thing about carry look everywhere, we enable all of these. We turn on the carry in. They all turn off immediately, and the carry out turns on the same tick. Yeah, so when you're trying to figure out how to do this, you know, you just ignore the first bit here. It's not really important. It's just the carry in. So for the second row of inverters, you know, connect to the one above it. And this one. So the farthest out one here, like this inverter, this inverter, this inverter, this inverter, always goes straight to the generate. And then, you know, so we're doing the first one. First inverter here. Like, obviously, we're not, we're ignoring the carry here, or the carry in. Connect to the propagate, go one back, connect to the propagate, and then the next propagate, go one more back, connect to that propagate, and that propagate, one back, connect to this one, this one, this one, this one, and this one, right? If we're trying to do this one, trying to connect to the same one that it's looking at, like a parallel, yeah, just like that. Connect to that one, and then that one, but not that one, not that one. So, yeah, anyway, that's pretty much that. I hope you're seeing the pattern here. If not, it's unfortunate, but I tried my best to kind of explain it and make it obvious. So, yeah, if you guys have any questions, leave a comment or shoot me a message on Discord. My Discord tag is capital M, lowercase r, underscore, capital I, capital O, hashtag 0132. That's my Discord tag if you want to add me. If you have any questions about this, I'm more than happy to help you out in the DMs. All right, thank you for watching, everybody. Goodbye.